Okay, folks, let's do number 3 here. I want to show you guys how to calculate phase shift, amplitude, and period. So let's say we take number 3, for example, here. Okay. All right. Phase shift is your horizontal translation, which is going to be, in this case, you would think that it's 4 to the right, but opposite hat says 4 left. Okay, amplitude is going to be your height, which is going to be 2. Okay, remember, height of a human being is always a positive number, same with this. Period, the way you calculate it is 2 pi, as you're always on your numerator, no matter what. That's fixed, no matter what the problem is. And then you put the 2 over 9 on bottom. Okay, I'm going to rewrite this as, okay, 2 pi divided by 2 over 9, which turns into 2 pi times 9 over 2, which gives you 18 pi over 2, which is 9 pi. Okay, 9 pi. So now, that's how you do 3m to find those 3 things, and we're going to graph in a bit later on. Now, with something like 4m, okay, with something like 4m, I'll do it in, let's see, what color should I choose? Gray. This would be, I'm going to just talk about 4m's period. You would do, okay, for 4m, let me do it right here. For 4m, the way you would do it for period, okay, is like this. 2 pi divided by 3 pi divided by 4, which equals to 2 pi divided by 3 pi over 4, which equals to 2 pi, keep, change, flip. Remember, I should have mentioned that earlier. Should use that analogy. And this would equal to, pi here. The pi's would cancel, okay? And you will be left with 8 over 3. Okay, is your period. So it will take 8 over 3 radians for the graph to repeat itself. Okay, here it would take 9 pi radians for the graph to repeat itself. Now, if you go on your calculator and do 9 times pi, just to get out of pi form and into decimal form, you will get 28.27. Okay? 28.27. So the way you interpret this is every 28.27 radians, the graph repeats itself. Now for 1m is the same thing that you do, except you're going to GCF out. In the yellow highlight here, you're going to GCF out a 2 pi. Okay? All right. Now, let's graph one of these here. Okay? So here are your answers for the phase shift and amplitudes here. Okay? Whoops. And let's graph these. Okay? Let's graph these. Okay, so watch this. Let's graph number 3m. Okay? And let's just, might as well fill these in. This is going to be 2 left. Okay? Amplitude is going to be 5. Okay, I should keep my colors similar. Amplitude is going to be 5. Let's go ahead and graph number 3m. Okay? I am going to do it right here. Okay? Now, if you look at the parent function of sine, it looks like this. Sine of x on Desmos looks like this. Okay? I'm going to focus on that. Okay? So it takes, the way you interpret this period is that it takes 2 pi radians for the graph to repeat itself. and the height is going to be 1. Okay, the height is going to be 1. So this is the period, which is 2 pi, and the height, which is 1, is the amplitude. So amplitude is 1, the period is 2 pi, this parent generic sine function that we put in on Desmos. Okay, but we're going to transform this sine function, and that's going to transform this graph. Okay, all right, so this is how it's going to work. So I'm going to draw an x-axis. Okay, whoops. I'm going to draw an x-axis. I'm going to draw a y-axis here. Okay, and our amplitude is 2 here, so I'm going to go 2 and minus 2. Our phase shift is 4, okay, 4 to the left. So instead of starting at 0, at x equal to 0 here, we're going to start at x equals to minus 4, okay, because of this, all right? So the minus 4s is related to, okay, here, all right? If this said 3 to the left, this would be minus 3. If this said 3 to the right, this would be, you would start at positive 3, okay? Now, here's where things get a little bit spicy, and it's really not even that bad, okay? I am going to add, okay, I am going to add 28.27. I'm going to add another 28.27 and add another 28.27. Okay, and I got the 28.27 here. All right. So, let's see what we get. I'm going to go minus 4 plus 28.27, and I get 24.27. All right. I'm going to take 24.27, add another 28.27, and I get 52.54. I'm going to take that 52.54, add another 28.27, and get 80.81. Okay? So the width in each case of this, of each of these pieces, is going to be 28.27. Let me highlight that a little better. The width of these is going to each be 28.27. Okay? And remember, the way you interpret period is every 28.27 radians, the graph is going to repeat itself. Here it was every 2 pi radians, the graph repeats itself. Here it's going to be every 28.27 radians is going to repeat itself. So it's going to repeat itself here just like it repeated itself there. And so the way it's going to be drawn is going to be something like this. Boom. Okay, and then you're going to go boom and boom. Okay? All right? Again, this took 2 pi radians, or 6.28 roughly, to repeat itself. This is taking 24.27 radians, excuse me, 28.27 radians to repeat itself. Okay, let me, this should be in blue. Okay? All right, so 28.27 radians to repeat itself, 28.27 radians to repeat itself, and same thing here. Okay? So let's go ahead and draw that now. All right? So I'm literally just going to trace over what I just drew. Okay, it's going to look like this. Your graph is going to look like, whoops. Remember, the highest it's going to get, it's 2. The lowest it's going to get is going to be minus 2. That's 1 period, that's 2 periods, and that's 3 periods. And you're done. Just graph 3 periods. Okay? And you would do the same thing for number 4 in terms of the same concept. I mean, it's a little slightly different, not slightly, it is different numbers. And this is going to roughly be 2.66. Okay? And because this is, okay, because this is 2 to the left, this is going to be minus 2. Okay, so I'm just going to pretend this is 4m. So we minus 2. The amplitude is going to be 5 and minus 5. Okay? Because of this, okay, and here, let's see if I can draw some arrows here, okay, because of that. So the amplitude of 5 gives you minus 5 and positive 5. 2 to the left gives you minus 2, okay, and you're going to add 2.66 each time. So you're going to add, so this 2.66 is going to be added to minus 2, okay. And then you're going to add another 2.66, add another 2.66. And then your graph should look something like this. It's going to be squeezed. It's going to be compressed more. Okay, it's going to look like this, and then this, and then that. Okay? Let me do that in blue. Okay, because I already used green there. It's going to look like that, and like that. Okay, I did that on the fly. I might have made some mistakes here and there, but that's a general picture. Okay, I'm applying the same logic from number 3m into 4m. Okay, folks, that wraps up the video. Thank you for tuning in.